Hello, this lecture presented by www.free-academy.com. We're going to be doing another practice problem on the definition of the derivative. This is problem 11 out of the textbook, and we need to find the derivative of f of x for f of x equals x to the third. And then we need to evaluate it at x equals 0. So in any problem with these, when we're using the derivative formula, it's just a matter of acquiring the pieces necessary for the formula, plugging them in, and then eliminating h from the denominator, which is usually quite easy once you have the different elements. So we already have x to the third here as our f of x. We already have f of x. So now let's just find f of x plus h. And that's just a matter of putting x plus h in everywhere we have an x in our original equation. So we replaced x with x plus h, and we've done lots of problems on combining and recombining functions, just in case that's unfamiliar with you. Now, it's not going to do us a whole lot of good in this form here, so we're going to need to solve this out, distribute it algebraically. This will be equal to x to the third plus, what's it, 3x squared h plus 3x h squared plus h to the third. I just did that in my head using the Pascal's triangle trick. But you can work that out algebraically just in case you don't believe me or you want to see how it's done yourself. So now we have a and b. We have, everything we need to do to solve the equation here. So let's write out the limit is h goes to 0 of x to the third plus 3x squared h plus 3x h squared plus 3x h squared plus h to the third. This is minus f of x, which is x to the third, and that's all divided by h. So we just plugged the values for f of x and f of x plus h into the equation here. Now we need to solve it down. And you're going to see that this is, fairly efficient. The x to the thirds cancel out, and now every single term in the numerator has an h in it, along with the denominator. So we're able to cancel 1 power of h with everything in the numerator. So this will be equal to the limit as h approaches 0 of 3x plus 3x squared plus 3xh plus h squared. Now we're going to apply the limit. We'll plug h equals 0 into that. Everywhere we get h equals 0 when we apply the limits, and this becomes 3x squared plus 3x times 0 plus 0 squared, which is of course equal to 3x squared, which is the right value for the derivative. Now we need to find this for f prime of 0, which is going to be 3 times 0 squared, which is equal to 0. Now we've completed the problem in the book. We found the derivative and we evaluated it at x equals 0. We got some more practice problems on these just in case this still isn't clear, and we're just going to run through the whole gambit. So check back.